Okay, today's lesson we will be still doing linear inequalities, but this time they're going to be a system. So a system then is two or more linear inequalities together. So it's similar to when we did a system of linear equations, it's just both of them are inequalities now. So if I look at this first one here, the pink line is representing x is greater than or equal to 3. It is a solid line, again, remember, because of this equal to part. If I plug 0 in here, 0 would not be greater than or equal to 3. So that's why this side is shaded and not the side with 0, 0. If I look at the second one, y is less than 2. There's no equal to part, so that's why your blue line is dashed. 0 is less than negative 2. 0 is not less than negative 2, so they shaded the opposite side of the line. So anything in pink is a solution of the pink equation. Anything in blue is the solution of the blue equation. So the part that is shaded together, which is right down here, is the solution of both of them. And that includes the pink line because the pink line is solid. So if I pick a point from down here, let's say I pick the point 5, negative 3. It's in both the pink and the blue region. So on this one, is 5 greater than or equal to 3? Yes. And on the second one, is negative 3 less than negative 2? Yes. So it worked in both of them, so our region is correct. Okay, you can also use a system of linear inequalities to identify all four quadrants. So quadrant 1, these lines are solid at the axis, but all of these are going to be greater than or less than. There's not going to be an equal to part. If x is greater than 0, so x is greater than 0 and y is greater than 0, and you can look at those and so on. Example 1 here, our first linear inequality. We're going to graph them. I suggest you use two different colors. Colored pencils work great. So if I look here, my y-intercept is negative 5. My slope is 2, so up 2 over 1. It needs to be a dashed line because there's no equal to part. And remember, for some reason, let me look and see if I can get, I can get dashed lines. I just need to mess around with it. Oh, maybe. Let me see if I can get that to work. Here. Ah, it keeps popping away from me. Come on. Try one more time. Here, and see if I can get over to it. There we go. So now it is going to work for me. So I want this dashed line there we go. And then I have to decide what side to shade. Is 0 greater than negative 5? In this case, 0 is greater than negative 5. And let me actually try to make this show up a little bit better. I'm going to use just my highlighters. Remember, because this line is dashed, that the line itself is not part of the solution set, just all the shaded region. Okay, now my second equation, I'm just going to find my intercepts here. If I put 0 in for x, I get 3 for y. Put 0 in for y, I get 4 for x. So 0, 3, and 4, 0. And let's see if my dashed line is still picked. I hope so. We'll find out. It is, but I want that to be a blue line. And I don't think I'm going to be able to get it changed. I guess not. I'm not sure why. I would do your two lines in the color that you're doing the equation in. And now I'm going to highlight. I have to decide if I'm going to do which side of 0, 0. Is 0 less than 12? Yes, so 0, 0 works. So I'm going to shade on this side of 0, 0. Okay, and remember, the region that has both of them shaded is your solution set. So your solution set is right there. It has two boundaries there. So for instance, let's say I choose negative 7, 0 that I want to try. So I tried in the first one. Negative 14, negative 19. Is 0 greater than negative 19? Yes. I tried in my second one. And I chose negative 7, 0. So 3 times negative 7 plus 0 is less than 12. Negative 21 is less than 12. Yes, it works in both of them. Our region is correct. Let's go ahead and turn our page and look at the next example. We have one more example here, and this time it's actually already graphed for you. You just have to come up with the two equations. To find my two equations, I'm always going to find M and B. That's the easiest way for me. And since this one's dashed, I need to make sure I pay attention to that. It's not going to have an equal to part. Okay, so I have to find 2 points exactly on this line. 0, 2, and I'm going to go 4, 2. So I go over 2, up 2, so my slope is 1. And it crosses the y-intercept at negative 2. So my first equation is y. I'm going to leave this line blank for now. 1x minus 2. And what I do, again, is I put 0, 0 in. 0, 0 times 1 is 0, minus 2 is negative 2. 0 is greater than negative 2. So the sign that goes into my equation is greater than. Remember, it doesn't have an equal to part because it's a dashed line. Now on my next one, again, I need to pay attention. This one's a solid, so it'll have an equal to part. I need to find M and B. So I'm going to clear off my writing just to make it a little bit easier to see. I'm going to choose this point right here, and another exact point could be right here for me. First of all, B is easiest to find. It crosses at 3. My slope then, I went down 1 over 1, 2, 3. So I get a slope of rise over run, which is 1/3. So I get y 1/3 x plus 3. I'm going to try 0, 0 in there. 0. 1/3 times 0 is 0, plus 3 is 3. 0 is less than 3, so that's my sign. And I need an equal to part there as well because it's a solid line. So there is my system of my equations, my two equations right there. Go ahead and complete the quick checks, and then look at your schedule to find your assignment.